Hello, Dr. Mayadun here. I am here to explain you some calculations in chapter 2. So you see there's a very first calculation to find the atomic mass of an element. So you know in the elements in the periodic table you see one mass um, on the top of the periodic table each box. So how to find this atomic mass? All the element in the periodic table, they have a lot of isotopes, not lot, I mean two or three isotopes. So they get the average mass of all the isotopes present in the mixture, and that's how they get the mass. Example, what is the atomic mass of oxygen listed in the box is 15.99. So let's see where the 15.99 comes. The isotope concept is very similar. Like if you think about oxygen in a bag, you have 100 milliliters, you have uh, all the three isotopes in oxygen. What are the three isotopes in oxygen? Oxygen 816, oxygen 817, and oxygen 0818. But why it listed six, like only the most abundant isotope is listed? So that's what we use 0816. You will see why it's most like you see these are the abundance. If you take 100 milliliter of sample, 99% of 75 will be oxygen 816. The remaining will be oxygen 817 and oxygen 818. So let's see how we are going to find this atomic mass. So you see in this question. So you see in this question, oxygen is the most abundant element on Earth's crust and the human body. The atomic mass is in its three stable isotopes. O816, the actual mass of O816 is 15.9949, and then it has 99.757%. O817 mass is 16.991, has 0.038%, and this one has um, 17.99. Round off, right? You see that they don't write 17.999. This 18 has 0.025. So in order to get the atomic mass, you get the mass of this first isotope, which is 15.9949, multiplied by the abundance. You get the mass of the second isotope, multiplied by the second isotope is 16.991, multiplied by the abundance. Third isotope, multiplied by the abundance. If I write, so we know the first isotope is, let me share my screen so you can see. So I'm taking um, 15.99, I think. I don't see it. It's okay. I think 15.99 9 into 15.99 into the percentage, which is 99.75 at 16.99 into percentage of that 0.038 plus and then you add 17.99 multiply 0.0205. So when you add all these three, this is in the hundreds, right? You get, and in this is in the percentage, and then you add it, and then you will end up with this number. So you because this is like in hundreds, so you can use like you can use two things. Okay, let me erase this line. Oh, sorry. You can use 0 when you divide 99 0.75 into 100, then it's going to be 0.997 because it's in the percentage. And then you get the this number, you divide in 100 and you get 0.2 zeros, right? 0, 0. Similarly, this one. So you add all these numbers and you will see at the end answer is 15.99 AMU. So that's how you make the atomic mass. Always get the mass of each isotope multiplied by the abundance. So I hope this help you to understand this question in your PowerPoint. And then I'm going to the next question. Okay, I have mole calculation. Always keep in mind, it's very important you know how to find the moles. How to find the moles? Always you can get the moles mass divide by molar mass. That's very important thing to know. How to find the molar mass? If it is an atom, you can find the molar mass. It's given like oxygen we divide by 16. But then if it is an element, like a simple element like water, H2O, you get the mass of hydrogen, which is 1 into 2 plus oxygen in the box. The atomic mass is 16. You add all these together, it's become 18. So this is how you find the molar mass and then the moles. In the mole calculation, it's very important to you know how to find the moles. Always given mass divide by molar mass. I can ask you in the exam two things or in the any assignment. Calculate the number of moles, calculate the number of atoms. Atoms, in when the atom come to the picture, you need to use the Avogadro's number. That means 1 mole has Avogadro's number of atoms. It's like 1 mole, how many atoms? Avogadro's number of atoms. It's like 1 dozen is 12. Only difference is just the big number. So let me go to this question. The question start with calcium is the most abundant metal in the human body. A typical human contain 30 moles of calcium. Determine the number of calcium atoms. Okay, so now they are giving me moles, asking atoms. So then if I have 1 mole, I have Avogadro's number of atoms, which is 6.022 into 10 to the power 23. 1 mole. Now I don't have 1 mole, I have 30 moles. How many moles? How many atoms? So then I do, okay, if I have 1 mole, I have um, Avogadro's number of atoms, so 30 moles. So 1 mole has Avogadro's number of atoms, 10 to the power 23 atoms. And then now I have 30 moles, right? So what you do basically, you multiply 30 moles cancel out, moles and mole cancel out, and then you multiply these two numbers and you can get the answer. We do the multiplication real quick. 6.022 into 30. So I get 180 into 180 into 66 into 10 to the power 23. And then you can write it in the scientific notation, because and then it's going to be 1.0 no, 1.80 1.81, we round off and then give 10 to the power 25. So this is how you do that part 1. Let me go to the part 2. Part 2 is asking um, the number of moles in the calcium in a simple sample containing this many atoms. So you have now they are giving you number of atoms. So you know if you have 1 mole, you have Avogadro's number of atoms, right? So 1 mole has 6.022 into 10 to the power 23 atoms. And then this many calcium atoms, how many moles? So you know um, 1 into 10 to the power 20 atoms. 1 mole has Avogadro's number of atoms 0 2. Sorry, wait a second. You don't see clearly that. 1 into 10 to the power 20 atoms, 6.022 into 10 to the power 23 atoms into 1 mole. So you divide it and then you give the answer. And you have the answer in the PowerPoint, so I let you do it. Okay. And then that's how you do this question. Okay, my third question. Determine the number of moles of carbon in 25 grams of carbon. Determine the number of moles of a carbon in 25 grams of carbon. So what is the molar mass of carbon? Molar mass of carbon is 12. So if you have 1 mole, it is 12 grams, right? So then, and then now you don't have uh, 12 grams, you have 25. So this is how I do the calculation. So if I have 2 moles, what is the mass? 24. So what I do, I take 25 grams. Okay, I know 1 mole is 12 grams. I round off this number and take it at this time. And then I do the calculation, gram cancel out, and then basically 25 divided by 12, I give my answer. And then part B, the number of moles of helium in 10.5 grams of helium. So for that, let me erase this one for a minute. It's not going. Okay. So helium, molar mass of helium is 4 because it's hydrogen, helium. You take the mass, so it's given 10.5 grams. 1 mole is 4 grams. That's it. Okay. So basically you divide 10.5 by 4. That's what I always showing you. If they ask you the moles, it's easy. Mass divide by molar mass. So this is mass divide by molar mass. Same way you can do the part C too. So hope this will help you to understand some calculations.